This is Advanced Math, Unit 7, Lesson 5. Today's lesson 7.5 is just a review of everything we've been doing so far. Review of law of sines, review of law of cosines, and all that good stuff, all the SOHCAHTOA. So review of 7.4. All right, number 1. A building is on a street in San Francisco. That makes a 12-degree angle with the horizontal. "15 yards down from the building, the angle of elevation is 73 degrees to the top of the building." How high or how tall is the building? Okay, let's go ahead and get our picture. A building is on a street in San Francisco that makes a 12-degree angle with the horizontal. That's a period. Okay, so here is my horizontal. And here is the hill. So this building is on a hill in San Francisco, and there's my 12-degree incline. Okay, so again, you have this hill in San Francisco, and it makes a 12-degree incline with the horizontal. Okay, you have a building on this hill. A building is on the street, 15 yards down. Okay, so I'm just going to remember now your buildings will be perpendicular with the horizontal. You don't have to draw this piece in. I'm just trying to show you that it is perpendicular with the horizontal. Okay, the buildings are not slanted off that way or either way. Okay, so you have this building. All right, now you're at the base of the building and you go 12, what does it say? Nope, 15 yards down. Now, that doesn't mean you all go all the way down to the tip. You can, it's up to you and how you'd want to draw it. We'll just go all the way down to the tip, to the bottom. Again, that is not what it implies, but it could. So this squiggly line here is the 15 yards. Okay. The angle of elevation is 73 degrees to the top of the building. Okay. 15 yards down from the building, that's here, the angle of elevation is 73 degrees. So when you walk 15 yards down and look up to the top of the building, the angle of elevation is 73 degrees. The mistake kids make is they put 73 degrees here in that corner, and that's not the angle of elevation. Remember, angle of elevation is from your horizontal line of sight, and then you look up. That there is your angle of elevation. Again, it's from a horizontal line of sight or horizontal line and then going up. Okay, so the angle of elevation's from this horizontal line going up. So I know it's kind of messy, but it's all of this together that is the 73 degrees. I will be redrawing this triangle because it is going to get a little messy. How tall is the building? So we're looking for the height of the building. All right. What does this mean? How do we find it? What we do need a little more information. So I'm just going to redraw this triangle right here. It's not a right triangle, so I'm not going to use SOHCAHTOA on it. I'm going to redraw it and the best I can. Okay, so redrawing it, the height is what we're looking for. That's the height of the building. What is this little angle in here? If the big angle is 73 and the bottom angle the little angle at the bottom is 12, you're going to do 73 take away 12. Again, if the big angle of elevation is 73, the little angle down here, the little angle of elevation is 12, you're going to do 73 take away 12 to see what you're left with, and that comes out to be 61. All right, I need more information in order to find, oh, I know this is 15. Still need more information. I can't use law of sine, I can't use law of cosine. I need another angle or another side. I do have enough information to find this angle in here. I'm going to have you hit pause, try to figure it out on your own. I'll give you one hint. We know if I were to draw a little horizontal line in there, that is a 90-degree angle. See if you can find out what that little angle is in there using your Z shape. Hit pause, try it on your own, hit play, and see if we're in the same spot. Okay. There's your 90-degree angle, as I stated earlier. I said use your Z. Can you see your Z here? Here's your Z shape. This is 12, meaning this little angle, and here is also 12. I know that's kind of hard to see, but you have your Z shape right in here. 12 and 12. So you do 90 plus 12 equals 102. 90 plus 12 equals 102. Okay, now we have enough. In order to use law of sines, which is what I like to use because it's easier, we would use an angle. We need an angle and its corresponding side. I know this angle, but not this side. I know this angle, but not that side. I know this side, but not this angle, but it is an angle I can easily find. So I'm going to do that. Since I'd rather use law of sines is easier, and it's really easy to find that angle. Add and subtract from 180. Do that now. 61 plus 102, subtract from 180. That gives you 17 degrees. Again, 180 minus 61 minus 102 equals 17 degrees. So now we can use law of sines because this is a matching set, an angle and its corresponding side. So that's where I'm going to start. Sine of the angle, 17 degrees, over its corresponding side, which is 15, equals, x is what I'm looking for, so I use its corresponding angle, sine of 61 over its corresponding side, x. Angle, side, sine of 17 over 15 equals sine of 61 over x. And then you're going to cross multiply and divide. All right, this here is what you plug in your calculator. Go ahead and do that now. Don't forget to close your parentheses here before hitting divide. Plug it in now. 15 times sine of 61, close parentheses, divide sine of 17 equals 44.872 when you round. So x equals 44.872 yards. All right. Okay. Number 2. Two sides of a parallelogram are 20 centimeters, squeeze that in there, and 35 centimeters. A diagonal is 40 centimeters. Find the value of the largest angle in the parallelogram. Find the value, this is the final question, find the value of the largest angle in the parallelogram. So we're looking for an angle, which most likely means we're going to be using an inverse key somewhere in there. All right, first thing I suggest is draw a picture. You will see this problem come up over and over. Now remember, our pictures, when I draw them, they're not drawn to scale, so you can't just look and say, I'm going to erase that diagonal really quick. You can't just look at it and say, oh, I'm looking for the largest angle, that's the angle I'm looking for right there because it's bigger than that one there. You can't do that because they're not drawn to scale. You actually have to find all the angles. But remember with parallelograms that these two are equal and these two are equal. So once you find one, you know this opposite one is the same, and once you find these two, you can easily find these two, knowing that they all add up to 360. Or remembering that consecutive angles add up to 180. However you do it, these two add up to 180, or they all add up to 360. All you need to do is find one angle. When you know that one, you know its opposite is the same, and then these two you can find either using 360 or 180. All right, so now I'm going to draw my diagonal in. The two sides of the parallelogram are 20 and 35. The diagonal is 40 centimeters. Find the largest angle. So I'm just going to find this angle first, only because of the way I've drawn my diagonal. That's the angle I'm going to look for because I have a triangle there. I'm not going to find that angle first because I'm drawing a line through that angle. Now, I often have kids do wonky things like they find this and they try to find these little angles by cutting things in half. Remember, in a parallelogram, these diagonals do not cut your angles in half. That's only for a rhombus, and this is not a rhombus. It's just a regular old parallelogram. So I will tell you this, you're not going to find anything over here by cutting in half or these little angles and doubling, none of that business. We're looking for X, and that is it for now. Okay, I can see I have a side, and I don't have any angle inside. Can you see that? I have a side but no angle, a side but no angle, a side but no angle, so I cannot use law of sines, which means I am forced to use law of cosines. Okay, trying to use law of cosines. We remember, I'm just going to write one form down. A squared equals, I can't use A again for now, B squared plus C squared minus 2BC cosine of what I started with, angle A. Okay, so angle A is now angle X. So just imagine that being an X, which means I'm using X here, a little x or side X. So all in all, remember these two are corresponding angles and sides. So if I'm looking for angle A, that means I'm going to use side A on this one. So if I'm looking for angle X, I'm going to use the corresponding side, which is the 40, not these two. opposite the 40, opposite the x is the 40. So I'm going to start off with 40 squared here, and I'm going to end with cosine x, which means these two numbers are going to be my b's and c's. Equals 20 squared plus 35 squared. And actually, it's okay if you have that down. I am just quickly, and I apologize for not stating this earlier, because I am looking for cosine of a, I'm going to move everything over first. A squared minus b squared minus c squared, and we did this on a previous lesson, equals negative 2bc cosine a, divide negative 2bc. And don't forget to put your parentheses when you plug it in your calculator. All right, so cosine of cosine of a equals a squared minus b squared minus c squared all over negative 2bc. All right, so when I do this, remember a and little a are x and x's corresponding side. Okay, so cosine of angle x equals all of this in here, the b's and the c's are these two sides. So for the a squared, that's going to be my 40. I know I'm running out of room here. 40 squared, again, because a and a are my x and side x. A, side A, x, and the side that corresponds with the x. And the b's and c's are my 20 and 35. So minus 20 squared minus 35 squared divided by parentheses negative 2 times 20 and 35. Okay, so plug that in. Should have given myself more room for this problem. Okay, so let's plug it in. Parentheses 40 squared, take away 20 squared, take away 35 squared, close parentheses. That's 40 squared, take away 20 squared, take away 35 squared, close parentheses, divide, open parentheses, negative 2 times 20 times 35, 0.017 dot dot dot, and then you do inverse cosine of that decimal by using your second key. So second cosine, second answer. Second cosine, second answer is going to take the inverse of that last decimal, and you end up with 88.977. Angle x equals 88.977 degrees. All right, now you're not done with the problem. This does not mean you're done. You're looking for the largest angle. We don't know, just because we drew it this way does not mean this is the largest. Now at this point I have kids, again, trying to find these little angles and doubling and cutting things in half and dividing by 2. Who knows what they're doing, but please do not do it. After this, you're not going to do any cutting anything in half. I'm just going to redraw this parallelogram again. This angle is 88.977, which means this angle down here is 88.977 because opposite angles are congruent. Again, how you find these two angles are up to you. You can add these two, subtract from 360, and then cut them in half because these two are the same. That you would cut in half. Again, they all add up to 360, so this plus this, subtract from 360 and cut in half because these two are the same. Or remember that consecutive angles are supplementary. They add up to 180. It's up to you on how you do it. I'll let you figure it out now and find the number. Okay, I ended up with 91.023, which means that this is 91.023. If you were to add all those up, you should have come up with 360. They're asking for the largest angle. These two are the same, these two are the same. Of all of them, the 91.023 is the largest, so that would be your final answer, 91.023 degrees. Now, keeping in mind on the test, I would be looking, this is your final answer, but when I check your work, I would be looking for all of this. I'd be looking for where you found your first angle, and then where you found your other angle, and then when you looked and said, oh, this one's bigger. And it may not be asking for the bigger, it may be asking for the smaller. You wouldn't know whether this is bigger or smaller until you find your second angle. So it may be the first angle you find, it may be the second angle you find, you don't know until you find them all. All right, that is it for this lesson.